All right, this one is a little bit more tricky. It says, which of the following statements is true? The mean of the density curve is true, is 2. That is true because you can see it is in the direct middle of this data set. Again, 2 would be the balancing point if you were going to try to balance this. And the median is 2. Yes, that's also true. And the height of the density curve is 1/2. And this is the one that's going to be the most difficult to figure out. The idea, though, is an area curve, like a normal distribution or anything weird and wacky like this, always has to add up to 1 in its area. And so the question is, if we have these two triangles, I'm going to do some tricky things here, but these two triangles are what we call symmetrical. So what you could do is you could imagine taking this shaded triangle. This is kind of an area trick. If you ever need to find the total area, you could fold it like this. And now you just have a box. All right, and this box goes from 0 to 2 now, if you're looking at that picture. And the question is, if this whole box, if this whole density curve has to have an area of 1, well then, what is 2 times what? 2 times what is going to give you 1? And the answer is 1/2. And so the height of the density curve is 1/2. I mean, the other way you can do this is you'll just find each triangle individually. You'll say 1/2 times the base of 2 times the height that I don't know, plus 1/2 times the base of 2 times the height I also don't know is equal to 1. And if you work this out, this ends up being just h plus h equals 1. That means 2h is 1, and that means h is 1/2. So many different ways of getting this answer, but turns out all three are true. Up next, we have a conversion question. And so this says that participants have a mean body temperature of 104 and standard deviation of 2, and this is in Fahrenheit. And now they want to analyze the work in Celsius, so they convert the data by following this formula. The idea behind this formula and the idea behind this question is, if you notice, one of these values is multiplying Fahrenheit. It's also multiplying -32, but then this -32 is only subtracting Fahrenheit. So some things are multiplying, some things are just subtracting, and the question is, how are the mean and standard deviation affected? And so the mean is, I believe this is the correct way I should use the word. You know what? I'm not even going to worry about it. The mean is changed by all operations. So in other words, we'll have to multiply the Fahrenheit mean by the 5.9 and subtract the 32 in the order that they told us to. But the standard deviation is only changed by multiplication and division. And so that means that -32 isn't going to change anything. So here's what that means. The new mean, if the current mean was 104, well then I'm just going to have to do exactly what it says. Do 5 divided by 9 times 104 minus 32. That's my new mean. I plugged the old mean into the formula that they gave me. So now I have 40, so it's one of these two. The next question is, which one is the correct standard deviation? And the idea is you take the current standard deviation, but you only apply the multiplication or division. And so the answer is D. All right. Up next, it says we have a chart for a male and a female, mean and standard deviation. And it says if both a male and a female complete 80 sit-ups, who completed more sit-ups relative to their gender? What this really means is, if we're looking for more, the question is, who has the higher z-score if 80 was the actual value? So we'll do that for Victor, the male. We have 80 minus the mean for males divided by the standard deviation for males. We'll calculate what that is. The numerator up top is just going to be -1 when you work it all out, and that's divided by 4.7. So you end up getting a z-score of -0.21. That's for the male. Now the z-score for the female, 80 minus the predicted 78 divided by 5.7. And that numerator is going to end up being positive 2 divided by 5.7. And we get 0.35. And that's enough to get this problem right, because the question is which one is bigger, and what that means is on the number line which one is further to the right, and this one's positive, this one's negative, so the female, Manuela, had more sit-ups comparatively. Last but not least, we have a stem and leaf plot again with 30 students, and we want to know the percentile of 40. So this time, let's see here, there are 1, 2, 3, or rather 4.0. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, and 26. We need all the ones. So there are 26 total that are either 4.0 or less, and that's out of, again, 30. And so the question is, well, what's 26 out of 30? And the answer is 86 repeating. So that'd be closest to the 86th percentile. And we did it. We're done.